In this video, I'm going to teach you how to perform this feeder element simulation. So there are two choices we have at hand, or we can perform using this simulation using implicit solver, or either we can use explicit solver. So in this case, for this blanking analysis, we're going to choose explicit solver. What next is we need to go to set the termination time. Since we are if you remember the load curve, we perform up to 0.35 seconds, right? And we're going to do the to select termination for that, and then time step as well. Time step between this is like this is an option, okay, option where you need to shorten your computation time. Okay, you can play around with this, so I will teach you how to do it later on, so you play around with this value. Okay, and also adaptive, where we want to control the mesh to avoid the excessive distortions of the mesh element of the sheet. Okay, so we can play around with this later. So first go to here, so you go to model part and then select here keyword manager, or you go to FEM, go to model part, you go to keyword manager. Okay, you end up to this as well. So click collapse, and then you know that you want to go to control, so collapse, or click all, collapse and control here. So you go to termination first. Termination, okay, down here. So here we decide the simulation will terminate at the end time is 0.35 seconds. So then accept, done, or then this is an option for us. You can play around with this. Okay, so if you since we want to shorten the temperature the computation time, so we ask the solver, this explicit solver, to not to calculate. Okay, so in my experience for this blanking operation, so with this mesh sizes, so it is better to use 0.0 this 0.001. so this 1 2 3 4 5. Okay, so you either one either this one, or maybe you remove 1 0 is also acceptable, but the result will be not so good. So if you increase and if you add another 0, so this is gonna increase the computation time. So I think from my experience earlier when running this blanking, so this value is suitable for this kind of meshes. So then accept, and then here also you can scale factor for compute time step, default 0.1. if higher procedure, the default is lowered to 0.67. so in this case you can use 1. The scale factor, just leave it as 1, is okay. Okay, then another option is that about the remeshing of the sheet material when the element breaks. Okay, when they are eroded. Okay, when the element eroded, so this you need to have some remeshing. So in this case, we want to control this remeshing. So I believe that we can use default, but then from in this case it is better to use here the time interval between the active refinement. The remeshing value here for the frequency is supposed to be 0.1. this is default value actually, 0.1, or you can add another 0. okay, but this gonna increase the computation time. And also you can add this tolerance here. You can play around with let's say we just use default, okay, we accept, okay, done. So we just use default for the beginning. Later on we will modify. Let's see how it goes. So accept, done. Okay, save. Okay, we finish.